Alrighty, so for number 4, we have a man with a mass of 80 kilograms is running at an unknown speed and jumps onto a boat with a mass of 30 kilograms. The boat is originally at rest and then starts moving at 4 meters per second when the man lands in it. The first question is, what is the velocity of the man after landing in the boat? Well, if you have your dude here in the boat and your boat is moving at 4 meters per second, I hope that your man is riding in the boat. So if your man is not going 4 meters per second with the boat, that means your poor man is no longer in your boat. So the answer to part A is simply 4 meters per second because that's how fast the boat is going and he's standing in it. Then it says draw a bar graph to represent the situation for the man and his boat. All right, so after they land in, or the man lands in the boat, both of them are moving. So let's say that they have this much momentum. Okay, so both of them are moving. That means they have a total of this much momentum. And originally, before the guy jumps in the boat was not moving. So that means that the boat had a momentum of 0. And the man was running fast. We have no idea how fast, but we do know that if we add the amount of momentum before, it has to be equal to the momentum after the guy jumps in the boat. Well, let's see, this is 1, 2, 3, 4, 5 boxes tall. So if it's 5 boxes tall afterwards, I essentially have something plus 0 has to equal 5 boxes tall. Well, that means that the man must have 5 boxes of momentum. And now we can figure out how much that is. So it says to write an equation to represent the bar chart information above. And actually, I want to look at both of these bar charts. Okay, so let's pause for a second. Let's go back to the other bar chart. So this man, we decided, has this much momentum to start with. All right, so there's the man with that much momentum to start with. And our boat was not moving, so that's 0. And then after the collision, they are moving both with 4 meters per second. Okay, well, that does not mean they have the same momentum, but it does mean they have the same speed. So if the man has a lot more mass than the boat, that means he needs to have more momentum than the boat. And they need to add up to be a total of the 5 boxes tall. So if this is, let's see, this is like 3.5 tall, and it has to add up to 5, that means we only need 1.5 boxes left. So I'm looking at this and I go, hey, look at this. I know I start with a total amount of momentum here. This total amount of momentum for the man and the boat has to be the same as what I started with. And so that's how much I started with. So that means I need to end with the same amount. And it's just going to be split between the man and the boat. All right, so that's cool and all. Now we need to write our equations. So we can do it either for the man and the boat as one object, or we can do it as 2 separate objects because they are moving at the same speed afterwards. Well, as you remember, momentum is P. Okay, so we have the momentum of the man plus the momentum of the boat is equal to the momentum afterwards, which is the momentum of the man and boat as one thing. Or I could write this as the mass of the man times the velocity of the man at the beginning plus the mass of the boat times the velocity of the boat at the beginning is equal to, and then this would be the mass of both things. All right, well, that would be the mass of the man plus the mass of the boat times the velocity of both when they're stuck together. Cool. So then all I have to do is plug in the numbers. So the mass of the man was 80. I don't know his starting velocity of the man. The starting boat's velocity was 0, though, so this would be 30 times 0. And then this would be equal to, all right, so the man was 80. and the boat was 30. And after they were moving at 4. All right, so 80 plus 30 is 110. All right, so 30 times 0 is 0. We still have 80 times my V naught. All right, well, I'm just going to keep on going right into part D because that's where I solve for V naught, or my starting velocity of my man. And so I have 80 times my starting velocity of the man is equal to 110 times 4, which is 440. And then to get that 80 to the other side, I divide both sides by 80. And I get an answer of a velocity of 5.5 meters per second for the starting velocity of my man. Now, I could have also done this with the other bar chart. And in fact, I get exactly the same thing, and I want to show you just how. So this part on the left, this is all exactly the same. So I'm just going to kind of copy paste it over. Okay, so this is all the same. So here I have the momentum of my man starting plus the starting momentum of my boat, and that's going to be equal to the final momentum of my man plus the final momentum of the boat. So momentum, boat, final. Okay, so this is going to be, again, momentum is mass times velocity, so this will be my mass of my man times the final velocity. And I don't know that velocity. So I'm just going to leave it as V, man. Okay. And then I've got plus the mass of my boat times the velocity of my boat at the end. Oh, I guess I should say man final. All right. So I've got mass times velocity for both of these. Now, this velocity is the same as that velocity because the man is in the boat. And so both of those are the 4 that we were given in the problem. So that'll give me a momentum of 440. And then all I need to do is divide both sides by 80 because this plus 0 thing I can ignore. So either way I do it, I get a starting velocity of the man of 5.5. So you do not have to do both ways. You just need to be able to do one of them. And that's it for number 4.